Good morning, Terry and Josh. Just doing the bending here. Let's just move this out of here. So you can see here, this is the finished part on our tooling, and this die here is the 32 mil tall that we have, or inch and a quarter, basically, inch and a quarter tall. And I'll show you why in a second why it needs to be tall. For us, if it isn't tall, so let's go back to this. First of all, let's just start from the beginning. This is a part with an inch and a quarter die and a 1/8 radius punch. That's what we use, a 1/8. It doesn't have to be 1/8. It could be less than 1/8. It could be 3/16 radius. Just no more than 3/16 radius punch will do. So let's just start with the first bend. So there's the first bend here. No big deal, right? And let's see here. I believe there's also no holes. There's no holes to worry about either. Let's go to the next bend. And this bend here, what I wanted to show you was this. These slots are in there, and they're in there for a purpose, and I want to show you why. When we bend them, what you're going to end up with is the slots are going to be flat in this area. They're not going to form around, and you actually want them to be flat, because what happens is this. You see this area where the flat area, the zone, protrudes past the surface. This prevents, when you're cutting, parts falling into the slots. Okay, so I can't stress that enough. So don't be alarmed when you bend it that this part here. Let's bend it first of all. Bends. Now I'm going to remove all the tooling so we can see it here. I'm going to just turn everything off for a second. All right. So in the model, it shows that it bends right here. Right? It shows that it's bending in this area. Let me just zoom in here. But in reality, when you bend it, it won't. It will be just like I said. There will be no radius here. This will jut out, right? And that's, like I said, very important because it prevents parts falling into your table as they vertically fall down. Let me just go back to that image here. So this is your air channel, right? This piece is the part of the slot that does not bend, and that's good. You don't want that to bend. It will jut out about 1/8 or more, almost 3/16. And because this point here is further than this face, less chance of dirt and dust and particles and slag and everything falling inside into the beneath the table, between the air channel and the under side of the slag trays. And hopefully that makes sense what I'm saying. Anyways, let's go back to bending. Let's show everything again. Okay, so change the view here. Zoom in. All right, so go to bending. There's here this bends up, and now we bend the other side, exactly the same order. Once. You'll see it doesn't hit the machine. I'm going to zoom out. Just pan this over a bit. It doesn't hit the machine. So far, everything's free and clear of hitting the machine. So you see, we have to raise this because if this die wasn't high enough, this was going to hit the part of our machine. So if I said, like I said, I would do a 1 or 2 foot piece of your channel as a mock-up, cut 4 or 5 pieces, have your operator bend them to see that there's no collisions with your machine. And ours, it does show it hits the nuts here, but that's not true actually. This is a little smaller than we on our machine, so it doesn't hit our machine. So next bend. And then of course, the last bend, we recommend in your plasma that you mark the center line. Can't stress it enough. Mark your center line, because you can't really use any reference point. My program here shows us using the backstop here. It's not really very good unless you use the backstop and you touch it on the tip of the slot that doesn't form. Okay, maybe use that as your backstop. But what we do is when we are actually cutting our slats, or air channels rather, when we cut this air channel, we actually put a plasma mark here and here for the operators to know where the center is. In fact, I believe on ours there's a little divot, a little V shape that we put in here so our operators know to center this for the last bend. Alright, so you can see here nothing's hit during the bending. Everything's free and clear. Nothing is damaged. Like I said, this punch can be 3/16 radius down to no radius. Just don't go bigger than a 1/4 inch radius because you, let's see here. Actually, you could use a 1/4 inch radius. I see all these bends here. Oh, this one here is, the radius is 5. Yeah, so yeah, don't go with a punch radius bigger than 3/16. Otherwise, you'll affect your bending. I hope that helps explain the bending and the order. So 1, 2, 3, 4, 5, 6, and then this is the last one. And make sure you scribe your line on there using your plasma. Just a 1/2 inch long line on each end, so your operators can center the last bend. Or they can use, where the slot doesn't bend here, they can use that edge. That's what we do actually. We do both. All right, that's it. Thanks. Bye-bye.